like, man, I'd like to buy a house one day, but I can never afford that. So.
No kidding. I even
The whole class.
Yeah, that's why I lost track.
Okay, so today we're going to look at yeah. 2.0, and this is the dimension
Rank.
of a subspace and rank a matrix. Okay, let's start from 2.1 and we'll start from the definition. What is a dimension? So the dimension of a subspace H of Rn, which we can write as written as done of H, is defined to be the number of vectors in a basis for H. It's actually just the number of vectors. The way I just told you yesterday, we'll see the dimensions of column space and the null space. Okay, for example, we write example number 4. Find the dimension of Rn and justify your answer by the dimension of Rn. So find what is the dimension of the whole vector space, the whole vector space. So basically for our vector space, the ordered basis in this case, which is B, is actually the standard vectors, which are E1, E2, up to actually En. Those are the standard vectors. The standard vectors. So the dimension in this case is the number of vectors here, and the number of vectors in this case are what? Rn. So then the dimension of Rn is equals to n number of vectors. Example number 5. This example displays an echelon form of a matrix A as follows. So we have our A, which is equals to 1, 2, minus 4, 3, and 3, 5, 4, and minus 2, 10, 8, and minus 4, minus 9, and 5, minus 7, minus 2, and 0, and 8, 7, and minus 6. So our echelon form, which we get 1, 0, 0, and then 0, 2, 0, 0, 0, minus 4, 1, 0, and 0, 3, minus 2, 0, and 0, 3, 0, minus 5, and 0. So that is our echelon form. So I'll give you a question like this in your exam, actually. Oh, and our exam is next week.
Next week. Wednesday or Thursday?
I think I'll give you on Thursday. Thursday. Yep. Okay, so number A, find a basis for the column space of A and basis for null space of A. Basis for the null space of A. So the first one is easy. You can actually get it directly from here. Actually get it directly from there. So the one for the column space. So let's look at the first one, the solution. For the column space, for the basis for the column space of A, you look at the one which has the column which has a pivot position. So if you look at this is the first pivot position. When you come to this one, this is the second one, and then when you come here. So the column, the pivot columns there are, so pivot columns are, so we can take this as the first, third, and the what? 1, 2, 3, 4, and the fifth, and the fifth. So the basis there will be what? You now take from here, the one which are having the pivot position here. So the basis will be, so you write it like that. And then now it will be 1, 5, 4, and minus 2. The next one is the third, which is this, minus 4, minus 9, minus 9, and 5. And then the fifth, which is 3, 8, 7, and minus 6. And that is the basis for the column space. Basis for the column space. So for the column space, it's so easy. So it's easy like that. So you just check the ones which has the pivot position. The pivot position. Okay, what about the basis for the null space? So in this case, then what we need to do is we now need to solve to get a basis for the null space. Then basis for the null space of A is the solution of AX equals to what? Equals to 0. This is the solution of AX equals to 0. So you already have the reduced, not even the reduced, the echelon form of A to be 1, 2, minus 4, 3, 3, 0, 0, 1, minus 2, and 0, 0, 0, 0, 0, minus 5, and then 0, 0, 0, 0, and 0. So what you do there, you need to get this, you write the augmented matrix, which R is of that form. And then we reduce it completely. So in this case, we have a pivot position here. So we need to make this one to be 0. We have our pivot position here. So we need to make this one to be 0. So you start from this. So before that, you even need to do what? Make this one to be what? 1. So you divide by -5. Again, this is 1 already, so you know. So finally, what you get reduced echelon form. So what you get is 1, 2, 0, -5, 0, and 0. 0, 0, 1, minus 2, 0, and 0. 0, 0, 0, 0, 1, 0, and then 0, 0, 0, 0, 0, and then 0. So that is the reduced echelon form. The reduced echelon form. Now, our basic variables there are, so we use this one as x1, x2, x3, x4, and x5 there. Basic variable are x1, x3, and what? x5. Free variable is x2 and what? x4 and x2 and x4. So our new linear system will now be x1 plus 2x2 minus 5x4 equals to 0. x3 minus 2x4 equals to 0. And then x5 equals to 0. x5 equals to 0. So then our solution set will now be x equals to x1, x2, x3, x4, x5 will be equals to x1 is, you take it to the other side, minus 2x2 plus 5x4. x2 is a what? Free variable. So x2. x3 is minus or 2x4, right? And then x4 is free variable, x4. And then x5 is 0. x5 is 0. So finally, this is equals to x2 minus 2, 1, 0, 0, 0, plus x4, 5, 0, 2, 1, and then what? 0. 2, 1, and then 0. Then the null space, which you can write as, and then for what? For any x2, x4. And these are elements of what? For any x2 and x4. So the null space here would be what? This one. So the null space, the null space of A has a basis. Minus 2, 1, 0, 0, 0, and what? And 5, 0, 2, 1, and 0. That is it. Now, what is the dimension? So number B. The dimension, find dim of column space of A and dim of null space of A. So what is the number? What are the number of vectors in the column space? There are how many? 3. So the dimension of column space of A equals to 3. The dimension of null space of A equals to what? Equals to 2. Equals to 2. Okay. Now let's come to the next definition, which is definition 2.2. The rank of a matrix A, which is written as rank A, is the dimension of column space of A, is the dimension of the column space of A, which is just rank of A equals to dim of column space. So what is, so in example 6, then find the rank of A in example 5. Find the rank of A in example 5. So what is the rank of A? So rank of A equals to dimension of column space of A, which is equals to what? It's equals to 3. So that is the end of section 2.9. That is actually the end of chapter 2. Now let's come to now chapter 3.
Like that's not next week, just chapter 2.
I feel like chapter 2 is a little bit small, so I think I'll give you up to like chapter 3.1.
Okay.
What we'll be doing today and tomorrow. 3.1 is just a determinant. So, and then the exam 3 will be the remaining section, which is chapter. It will be from 3.2 up to where we'll reach before the third exam. I think we'll reach 5 actually, if we get some time. The time is moving so fast.
Yeah.
The summer is almost gone.
Are we halfway there yet? I feel like we should be.
I think we're over halfway at this point, right?
Of
This semester.
yeah, actually halfway of the semester. This is the 4th week, if I'm not wrong.
Yeah, these last 2 weeks from you just gone right.
Yeah, just gone like that.
So that's summer semester's next, just quick.
It's a sprint.
It is, yeah.
It's a
It is
lot
just
to do
spring.
regularly.
actually. Summer starts when? In June or what?
I don't know.
Are we almost finishing our spring? Because I think summer is like, I think it's from June. This month, 20 something.
Yeah. I don't know.
Yeah, I think it's actually from this month up to like September.
I think so. That sounds about right. Either that or it starts July.
Yeah,
Technically, that's when summer
because
starts.
spring started in, I think, March.
Yeah. Yeah, all I know is I love the weather out here. I love the summer here.
Yeah, this summer is not crazy. It's not like last summer. By this time, last summer, it was so hot.
I spent the last 6 in Nevada, so it's, my buddy's there right now. It's 104 today
Oh.
in the morning, so it's
Yeah, that's
uncomfortable.
Okay, now let's start chapter 3.1 and we will do the introduction to determinants. Introduction to determinants.
You've calculated determinants before.
Yeah,
right?
for
Is this kind of the same?
2 by 2. Yeah.
Yeah,
So we did the 2 by 2.
gotcha.
The 2 by 2 one. So we now want to do the more than 2. If n is greater or equal to 2. So how will we get the determinant? So we will actually use the one which I was telling you, we call it the cofactors. So you just delete one row and the other one, and then you can use it to 2 by 2, which you're able to solve it to get a determinant, because it's easy to get a determinant over 2 by 2. You just cross, multiply, cross and cross. Okay, so, and we start by our notation, which I was telling you about. You're Ethan, right? Oh, I have a son actually who is called Ethan. He's 5 years.
It's a funny age.
Yeah. So A equals to, if we have our A equals to A11, A12, all the way to A1n, A21, A22, A2n, and then AM1, AM2, AMN. We have our A like that. Then we can actually write determinant of A. Determinant of A to be equals to. So you just use this. Just use like the absolute value A11, A12, all the way to A1n, A21, A22, A2n, AM1, AM2, AMN. So that is how we get write the determinant, or you can just write determinant of A to be equals to A. Right. So if you see a question and someone is just putting the two lines there, then it means you should get the determinant. Should get the determinant. Okay. Let's start by defining what a submatrix is, and this is what we will use to get a determinant of a matrix. A submatrices. Submatrices. And this section will just start. So before this, let's just write one. The n by n determinants. And let's start by 1.1. 1.1, let's start by defining what submatrices. Submatrices are submatrices. Now we assume that n is greater or equals to 2. Let's use the assumption that n is greater or equals to 2. The ij submatrix, the ij submatrix of A is the n minus 1 by n minus 1 matrix Aij is the n minus 1 by n minus 1 submatrix Aij obtained by deleting the ith row and the jth column from the matrix A. From the matrix A. So to get the ij matrix, submatrix, then we obtain this one by deleting the I and the J, the I column, and the ith row and the J column. For example, example number 1. Write out all the 2 by 2 submatrices of A, which is equals to 1, 3, 5, 2, 1, 1, 3, 4, 2. Write out all the 2 by 2 submatrices. So what you need to do is we need to delete the first row, the second column, second row, first row, second column, like that. So the first one is to get the first one, which is solution. To get A11 is we delete the first row and the first column. So deleting the first row and the first column, which that means you delete that and that, which will give you 1, 1, 4, and 2. To get a second one, which is A1, 2, we delete the first row and the second column. A1, 2, we delete the first row and the second column, and we get 2, 1, 3, and 2. Okay. A1, 3, we delete the first row and the third column, the first row and the third column. Okay, so we get 2, 1, 3, 4. Then we go to the second row. A2, 1, we delete the second row and the first column, the second row and the first column. Then we get 3, 5, 4, 2. A2, 2, we delete the second row and the second column. Delete the second row and the second column. Then we get 1, 5, 3, and 2. And then A, 2, 3. Yep, A2, 3. We delete the second row and the third column, which we get 1, 3, and then 3, 4. And then we come to the last row, A3, 1. We delete the first row, the third row, and the first column, which is 3, 5, 1, 1. A3, 2. The same thing, 1, 1, 5, and then 2, 1, and then finally A3, 3 equals to 1, 3, and then 2, 1. So those are the sub matches. Okay, now looking at this now, then we will see how we get a determinant. So to get a determinant of 2 by 2, we just do
Subtract.
yeah. Okay. Now, what is the definition of this determinant? So 1.2 definition. Now, number 1, if n equals to 1, then the determinant of A, which is equals to A11, is equals to what? Is equals to determinant of A, which is what? Which is just A11. And is equals to 1. If we only have one inch, then the determinant will just be that inch. Now, if number 2, if n is greater or equals to 2, then the determinant of A is determinant of A, which is equals to, now that entry which you deleted, that value which, like for example, here we have this, we deleted this, the first one, we deleted the first row and the first column. So this value here is what we take this, and then now we multiply by the submatrix. Okay, so it is 1 multiplied by the submatrix, which is A11. Go to the second one, 3 multiplied by the second submatrix where you deleted, which is this and what, and determinant of this. Okay, sorry about that. So you take this and the determinant of the submatrix plus or minus. So actually, the determinant of A is the same as A11 multiplied by determinant of the submatrix. That submatrix. So A11, that entry is A11 multiplied by determinant of the submatrix A11. Minus, so it is actually minus the first one minus the second one, which is A12 determinant of A12 plus A13 determinant of A13 minus, you continue like that, and then plus minus 1 n plus 1 A1n determinant of A1n. Okay. So if n is like even, then of course this one will be what? So if n is like 1, then it's 1 plus 1, which is 2. 2 raised, negative 1 raised to 2 is positive, right? If n is like 3 or 2, then 2 plus 1 is 3. Negative 1 raised to 3 is negative. So it is alternating positive, negative, like that. So you continue like that. Actually, what you're doing is you're just adding this and this. So 1 and this. Like for example here, 1, 1 is what? 2. So negative 1 raised to 2 is 1. The next one is 1, 2, and 1 is 3. Negative 1 raised to 3 is negative. The next one is 1 and 3, which is 4. So it will give you positive like that. So then this is the same as the summation from j equals to 1 to n of negative 1, 1 plus j, A1j, determinant of A1j, determinant of A1j. So it's like that. So the summation. So you see this 1 plus j here is this, and then 1j. So provided that all the n minus 1 by n minus 1 determinants are already defined. Provided this A11, A12, determinants of A11, A12 are already defined. Okay. Okay, example number 2. Use definition to compute the determinant of A, which is equals to A11, A12, A21, A22. Use the definition of R to compute that. So how will you use that definition? So basically, we are using, so we take this A11, determinant of A11, where we delete the first row and the first column. So in this case, to get a determinant here, so solution, determinant of A is equals to A11 here, determinant of what? A11 minus A12, determinant of A12, right? But we delete the first row and the second column. Then this is equals to A11, determinant of, so determinant of A11 here is what?
That's just A22.
A22. Determinant of A22. Minus A12, determinant of what? A21. So basically, this is the same as A11, A22 minus what? A12, A21. A12, A2. And that is what we were doing last time. So it's just the same as A11 multiplied by A22 minus A21 multiplied by A12. A12. Okay. Now, let's compute example number 3. Compute determinant of A, which is equals to 135, 211, 342. So we can actually use the one fast. So take this and then multiply by determinant of this. Take this, multiply by determinant of this and this. Take this, multiply by determinant of. Okay. So this case, determinant of A is the same as A11 multiplied by determinant of A11 minus A12 determinant of A12 plus A13 determinant of what? A13 determinant of A13. So in this case, then this is equals to A11 is 1, and then determinant of 1142 minus A12 is 3, determinant of 2132, and then plus 5, determinant of 2134. So finally, using this up here, then it is 1 multiplied by 1 multiplied by 2 minus 4 multiplied by 1 minus 3. 2 multiplied by 2 minus 3 multiplied by 1 plus 5. 2 multiplied by 4 minus 3 multiplied by 1. And this is giving us what? This will give us 20. Any question up to that?
I did have a question.
Mhm.
So why do you only use A11, A12, and A13? Why not use like A21?
Okay, we're coming to that now. Yeah. We are coming to that now. So that one is now what you call the cofactor. So you use now the cofactor method. So you can basically still use, this. You can still use this. You can still use this. You can still use this, and you still get the same. The same determinant. So this is leading us to what we call the cofactors. The cofactor method. So 1.3, the cofactor. And we name this one as Cij, the Cij. Now, if n is greater or equals to 2, n is greater or equals to 2, then the Ij cofactor of A, the Ij cofactor of A is Cij, and this one is equals to -1 I plus j, determinant of A, I, j. You see now, it is not like the previous one where I was what? Was using 1. This one, you can now use the second row or the third row. So you just come and place it here. If it is the second row, then it is 2 plus 1. Maybe 1, like that. So Cij equals to -1 I plus j, determinant of Ij. So Ij is just the one which you delete. It is the row and the column which you delete. And we have determinant of A to be equals to A11 C11 plus A12 C12 plus, just like that, plus A1n C1n, whereby this is the same as summation of j equals to 1 to n. A1 j C1 j. A1 j C1 j. So you can use the first, but decide to use the first row. So in this case, we're just using the cofactors on the first row. So let's find the cofactors here. Example number 4. Find all the cofactors Cij of A equals to the same matrix which you just used: 1, 3, 5, 2, 1, 1, and then 3, 4, 2. Let's find the cofactors there. Let's now find the cofactors. Let's find C11, C12, C13, C14. Okay. Solution. So in this case, we have we delete this 1, 2, 3. 1, 2, 3. We have exactly nine cofactors. So we have 9 cofactors. So the first one is C11, and C11 is equals to -1 1 plus 1 A11. Okay. So C11 is -1 1 plus 1 A11. And A11 is gotten by deleting the first row and the first column. And this is equals to -1 1 plus 1. A11 there will be what? Sorry. Determinant here. Let me put here determinant. Okay. Let me put the determinant of A11. So determinant of A11 there is what? 1, 1, 4, 2. And this is equals to what? -1 raised to 1 plus 1 is 1. Determinant of this is 2 minus what? 4, which is equals to -2. Then you carry on like that. C12 equals to -1, 1 plus 2, determinant of A1, 2. And this will give us -1, negative, right? So it will give us negative outside there. And determinant of A11, which is 2, 1, and then 3 and 2. And this is giving us -1, 4 minus 3. And this is equals to -1. Next one, C13 is equals to -1, 1 plus 3, determinant of A13. And this is equals to 1. Determinant of A13 is 2, 1, and then 3, 4. And this is equals to 8 minus 3, which is equals to 5. Come to the second row, C21 is equals to -1, 2 plus 1, determinant of A21. And this is equals to negative. Determinant of A21 is 3, 5, and then 4, 2, which is equals to -6 minus 20, which is giving us what? 14. It's giving us 14. Next, C22, which is equals to -1, 2 plus 2, determinant of A22, which is equals to that is positive, determinant of 1, 5, and what? And 3, 2, which is the same as 2 minus 15, which is minus 13. A23 equals to -1, 1 plus 3, 2 plus 3, determinant of A23, which is equals to negative 2, 3, 2, 3, 2, 3 is what? 1, 3, and 3, 4, which is equals to -4 minus 9, which is the same as what? 5. It's equals to 5. The third row, C13 is the same as -1, 1 plus 3, determinant of A13, and this is the same as 3, determinant of 3, 5, 1, 1, and this is equals to 3 minus 5, and this is giving us what? 2. C23 is equals to -1, 2 plus 3, determinant of 1, 5, 2, 1, which is equals to -1 minus 10, which is equals to what? 9. And then finally, C33 equals to -1, 3 plus 3, determinant of 1, 3, 2, 1. This is giving us 1 minus 6, and this is equals to what? -5. It's 5. Those are the goal.
Question. So what's different from what we did here and in the last example?
And the last example.
Yeah.
So the last example, we were just using the first row.
To find the determinant,
Yeah, we're just using
and
the
this is
first.
just find.
So this one, you can actually now use this. I will show you how to use this to get a determinant. I'm going to show you this.
So is it much faster to use the first example then to find the determinant? than this?
Yeah, you can actually use it is actually similar, but we did not define what cofactors are in the past.
Yeah.
But here we just define what cofactors are because in the first one we're just using 1 here instead of I. So in this case, you can actually come and use the second row. So you can just use the second row here, using the core factor. So the second row will just be all these instead of 1, you just use 2, 2, 1, 2, 2, 2, 3, like that. If it is the column, then you can maintain the first column there. So this will just be 1, and then you just change. Yeah, like that.
So each.
So you can either use the row, the column, like that. So
So it should all, whatever you do should be 20.
yes,
Is on the first
yeah,
example?
it will just be that. So you can just use. So I'll show you how to use the first one. Like that. Yeah. Okay. Now let's start this by this now section 2, which is the row and the column expansions. The row and the columns expansion. So let's start by looking at the first one, which is the row expansion. So we can actually use the row. You can see use the row. So we start by looking at the row. Now, if n is greater or equals to 2, then the cofactor expansion of determinant of A across the ith row is actually the determinant of A equals to AI1 CI1 plus AI2 CI2 plus AIN CIN, which is the same as the summation of j equals to 1 to n AIJ CIJ. So you can use the row. So you can use the row here. So this row is just taking the cofactor. So if you use the first row, then it will just be A11 and then C11 plus A12 C12. So you're just using the first row. As long as you solve the cofactors. As long as you solve it. Okay. So you can use the row. So you can use the row. For example, example number 5. So in your exam, I'll not ask you which maybe I'll ask you, but I'll show you how you can actually do it easily when you're given a very big matrix, how you can easily get the determinant. Example number 5, compute. 1, 3, 5. Just the same matrix. 2, 1, 1, 3, 4, 2. By the cofactor expansion across the third. Now let's use the third row. Let's use the third row. Now, if we use the third row in this case, then determinant of A will be what? Will be A31, right? Third. So we're using third. So A31, and then in this case, C31, right? And then plus A32, C32 plus A33, C33. Okay. All right. Okay, now A33 in that case is what? Is 3. C31, we got it here. C31 is what? C31. What the hell was I doing here? So useless. So this is actually 3-1 here, right?
Yeah.
And then 3-2 here. And then this is 3-3. Yep. So C31 in this case is 2, right? So 2.
-2.
And it's actually -2. Yep, it's actually -2. Yes, it's actually -2. So it is multiplied by -2 plus 3-2, there is 4 multiplied by 3-2. C32 is what? 9 plus 2 multiplied by C33 is -5. And this is giving us -6 plus 36 minus what? 20. And this is equals to what? -20 is -10. And this is equals to what? Minus, because this is 30 minus 10. This is equals to 20. That is equals to 20. Okay. You see how it is coming by, right? That is how we do it. Now, what about when you use a column? So the column, so 2.2, the column expansion. Same thing. If n is greater or equals to 2, then the cofactor expansion of determinant of A down the jth column is determinant of A equals to A1j, C1j plus A2j, C2j plus ANJ, CNJ, which is the same as the summation of I equals to 1 to n, AIJ, CIJ. So we can use the column. Now, example number 6. Compute determinant of 135, 211, 342 by the cofactor expansion down the second column. Down the second column. So let's use this column. So then, determinant of A, the determinant of A equals to, we are using the second column. So determinant of A will be equals to what? Will be equals to A1. A21, and then what? C21 plus A22, C22, and then plus A1, A32, right? And C32. So we are using this column here. This column. So this is A11, this is A12. A2, C. So therefore, then determinant of A is now equals to A21 is 3 multiplied by C21. C21 is what? 14. Plus A22 is 1 multiplied by C22, there is negative 13. Plus A32 is 4 multiplied by A32, C32 is what? And this should give
Is it
us
supposed to be A23?
A23, right?
Yeah.
Yeah.
Yep, A23, yep. Third row.
Well,
It is A32. Third row, the row and the column. So we usually 3, 2. So we usually start from the row and the column.
is it the same thing as 2, 3 though?
No.
Why is it 2, 1, 2, 2, and then 3, 2?
Because we're using the second column. We're using this column here. You get that point?
Yes.
Yep. So we are using this column. So we are taking this one multiplied by the cofactor. This one multiplied by the cofactor. This one multiplied by the cofactor. So this is A21, right? And then multiplied by C21. So it should actually be the same. 2, 1, 2. A22, which is this, multiplied by C22, which we get by getting the cofactor. And then finally, A32 multiplied by C3. Okay.
Is it the same thing as putting 2, 3?
2, 3.
Doesn't that lead you to the same place?
2, 3 is a different one. 2, 3
Is 2, 3.
2, 3 is the second.
Column, third row.
2, 3 is the second column and the third row. So it is this.
It'd be number before on that matrix, second column in, third row down, and number 4. I do think you might have gotten 3 of those numbers mixed up there.
Oh, really?
Yeah. So the 2, 1, 2, 2, 2, 3 is, as you're going down that second column. Unless I'm getting my coordinates mixed up here.
So it is maybe a mix up here. So it is 1, 1, 1, 2, 1, right? 2, 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 3, right? Yep. So in this case, then we are taking this, which is 3, and 2, 1, and 2, 1 there is.
I think your numbers are right,
Your
'cause
numbers
you're
are-
going down the column 3, 1, 4, right?
Yeah.
But I think just what you wrote there for the.
Oh,
Yeah, just your subscripts on A and C.
so this should be 1, right? 1, 2.
It's a column then row, right? Or
So
row
it is
column?
so we are taking this.
Yep.
So it is this
Second
is the
column.
this is the row. Sorry, this is actually the row. So it should be 1,
1,
2.
2.
Yep.
And
It should actually be 1, 2.
Ah,
So this should actually be 1, 1, 2. And then this is 1, 2. Yes, sorry about that. So 1, 2 is 3 and what? 1, 2 there is what? Is negative 1. So this is actually negative 1. So negative 1. Yep.
Row.
So it's row and column. So row and
Row.
so column. Yep.
Wait, so then did we do that wrong in the last example? then?
So did we do it wrong?
Let me check. I don't think we did.
831.
So it is the,
No,
The-
we did it right.
this is right. Yeah. Previous one is right.
Yeah.
Eh,
First we changed the second one's gonna be changing.
Yeah, so this is -3 minus 13 plus what? 36. We should give us what? 20. Is it giving us even 20? Yep. So -3. -3 plus -3 minus 3 is what? Yep, it's giving us 20. That is how you do it. That's how you do it. So, remark. Use the cofactor expansion across a row or down a column that contains as many zeros as possible. So we have seen how you can actually use the row or the column. So when you're given the matrix and then you're just told to find the determinant using the cofactor, then you just select the row and the column which has as many zeros as possible.
That make it easier.
Yep, it makes it easy. For example, let me give you an example and then we'll solve it when we meet. For example, example number 7. Compute determinant of 5 minus 2, 4, 0, 3 minus 5, 2 minus 4, and 7. So you can actually go down the column or across. All right, I will see you tomorrow. Okay, tomorrow I think we'll have a worksheet tomorrow. And the worksheet will just be getting the null space of A and the column space of A and rank. This will be the worksheet tomorrow. Just like the example that we did.